what you've done so far is you've changed that into this. So I'll need you to answer the next question for me, miss. If I gave you this, what would the answer be?
4 times 3, 12x to the power of 3.
Very good. And if I gave you this, 5 times x to the 1, what would your answer be?
Oh, no, that's interesting. 1. Because it would be 5x to the power of 0. So that's 1. Oh, but 5 times 1, 5.
X will go to the power of 0, absolutely. So what would the answer be?
5.
Absolutely. So what would the answer be if I gave you, we'll just do both of those together. 2x to the 3 plus 7x. What would the answer be if I get that?
So that would be 6x squared plus 7x to the power of 0, so that would be 7 plus 7.
So 7. So everything is dropping by a power. 3 drops down to 2, 1 drops down to not being there at all. If that's the case, if I gave you this number here, x squared plus 4, what would the answer be this time?
X squared. And then it will be 1 times 4 to the power of 0.
Hang on, what's this piece here?
Oh, 2x.
2x, yes.
And then that will be, that's 4 to the power of 1, so that's 1 times 4 to the power of 0. So that's just 1.
How many x's are there?
There's no x's.
The answer is no. If you want to prove to yourself why the answer is no, you could say that's 4 multiplied by 1, which is 4 multiplied by x to the 0. So when the 0 comes down, I get 4 times 0 times x to the minus 1. But anything multiplied by 0 is 0.
Yes.
But it's easier just to tell yourself, if there's an x squared, it drops to an x. If there's no x at all, it disappears.
Yes.
That brings us up to this question. Suppose I've got, just for example, x to the 5 plus 2x cubed plus x, 7x plus 3. What would the answer for that be?
It's 5x to the power of 4, 6x squared plus 7.
Perfect. Now, for uses, it's a game. So if I have this, differentiate that.
2.
And if I have this, differentiate that.
7.
What can you tell about the answer 2 and the answer 7? What do they have in common?
They're the coefficient of x.
Coefficient of x, yes. What else do they have in common?
The whole numbers.
The whole numbers, okay. Differentiate that.
So that would be a half x to the power of 0. Oh, it's, yeah, half x, wouldn't it be to the power of 0? So it would be half.
It would be a half. Now, they're not whole numbers anymore. What do they have in common?
Oh, that's good, okay. They're the number in front of the x. They're
the number in front
the gradient.
Bingo.
They're the gradient.
Good girl. Gradient. It just so happens that if I do a line, if I get the differentiation of that line, I actually get the gradient of the line. So we can use this when we don't have lines, when we've got curves. This here looks like x squared plus 2. I know if I differentiate it, the answer will be 2x. Now what does that mean? If we've just discovered this thing makes gradients.
Oh, ho, ho. You could find the gradient where you give me a value of x and I could just times it by 2.
I give you a value of x, you could tell me what the gradient of the line is there. So let's say I took 4.
So it'll be 8. The gradient will be 8.
The gradient will be 8. Well, exactly what is the gradient of 8? There's the 4. Imagine it hits that line there. What would the y-coordinate be if the x-coordinate was 4?
And that's for the y equals, what was that, 2x plus 2? I can't read
x
it.
squared plus 2.
So if it's 4, it's going to be 18.
18. So this coordinate here is 418. The gradient we've just discovered, you said, if I use the number 4, the gradient is 8. What line has a gradient of 8?
The line that just touches that.
The line that just touches it. What's the name of the line that just
The
touches it?
tangent.
Bingo. And I can go one step further